terms. So all we have to do is find out when our AN will be 2P. Yes? P means present value. Okay, I'm just used to P. You call it future value, present value. Right? Then 1 plus 5.5, 100 times 4 raised to power 4n. So some of you did it, the normal way. You work it out, you cancel the value of P, you use logarithm, and of course it's correct. So you could also just use your calculator and just put in these details. Okay? Your future value, present value, use 1. Future value, we have to be the opposite sign. Remember, when we're doing it in class, if our present value is 500, we say minus 500. Remember that? We'll use a negative, so you just change those negative values. Let's try this in the calculator. Let's try it in the calculator. Go to where you have that function. Let me see if my emulator can work. Quickly, go to that function.
Try to make sure it's bold. Hopefully that's not too bold.
Okay. Yes, are you there yet? I think it should be in financial. Okay, so that's compound interest, F2. So in your F2, so we are looking for present value n. You can leave n, whatever you have in n, because we are looking for the value of n. All right? Are you there yet? Talk to me, please.
Yes.
Okay. Your interest is 5.5. So my present value, I can put 1. The PMT, leave it blank. Your future value, then put the opposite, minus 2. P slash y is period per year. So there are 4 periods in a year. C comma y, put the same thing. Then if you look at my screen, there is n here at the top of F1. So that's what we're going to click. And that gives us 50.7 something. Understand? So that tells you the number of periods. It's not the number of year. Okay? It's the number of periods. Can you zoom in into this, miss? Did we get that? It's the number of periods. Do you want me to go over that again, or is it okay for everyone? Is it okay? All right. So that's the number of periods, not the number of years. But how many periods are in a year? 12, right? No, 4. So you divide this by 4. So our 50.75 blah 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 exit. Okay, let's just divide that by 4. Just tell me. Speak, please. 12.7. Now, 12.7. We are talking about, the question is about year 2000, right? The question is saying year 2020. We want to know in what year. So we are going to add that 12.7 to this. That would be 2032.7, right? So some of you wrote 2033 because you rounded it up. By 2033 is not double yet. So you can't round up. Look here. You have n is equal to 50.7 approximately. You divide that by, is it 50.7? 50 point something anyway. You divide that by that 4, you got 12.7. I don't know what 50 point this is. So you got 12.7, right? Now, year 2020 plus 12.7 is 2032.7, like that. It means it is after year 2. By the time it is double, it's already past. You have already said, Happy New Year, welcome to a new financial year for year 2032. But you have not said Happy New Year for the new financial year of year 2033. So you can't say that it will be double by the year 2033 because it's already double before that year. Do you understand that? So you can't round up. When will it be double? Not in the year 2033. Do you understand that? In fact, by the year 2023, it's over double. Okay? And find the year in which the amount will become double of what has been invested. So, there is no, I think that was a minor error. Some of you rounded up. You use that, it's like a floor function now. You use the integer part alone. Because the others is not complete yet. Okay? Anyways, quickly, because of our time. A six-sided bias die is weighted in such a way that the probability of obtaining a 6 is 7 over 10. That's very biased indeed. The die is tossed 5 times. Find the probability of obtaining at most a 3. Now, this is a binomial distribution, isn't it? What they want you to know is also to recognize that it is binomial. So you can see, even for recognizing it is binomial, how do you show that it is binomial? You write this. If x is a random variable, then x is binomially distributed. So just put this, we know that you mean, yes, it is binomially distributed. There are 5 trials and the probability of success is 0.7. So even that alone gives you something. Then you can make use of calculator. I believe we still remember. So I've opened some of the calculator functions here. You all have it. Okay? Does everybody remember how to use this? So but this time around, your calculator does not have the cumulative one. Right? Because of the level of calculator you are using, isn't it? So you have to do addition. Okay? Hello? Remember, this is about at most 3. Out of how many? Out of 5. At most 3. So which means from 0 to 3. Isn't it? So you can make use, you can find 4 and 5 and subtract 1. Subtract from 1. Hello? Talk to me please. So you can do 1 minus probability of 4, probability of 5. Here you can do those addition because it's a discrete random variable or discrete probability distribution. Okay? So you can make use of that because of the kind of calculator you are using. That's the point. But if you use the Form 5 type of calculator, you can use the BCD, the cumulative distribution. And that is the manual that I'm showing you. Unfortunately, that's not the one you have. So you're welcome to check, get calculator from Form 5. It's easy to trace also. Do you want me to arrange some Form 5 calculator for your exam? You're allowed to use 2. You're allowed to take 2 into the all, but I think not maximum, not more than 2. So if you want to have one of these and one of that, please talk to me. I will arrange from some Form 5 they can release your calculator for the exam. Okay? But then you should practice the functionality, how it works still. It's similar. It's similar. The only difference is, okay, is maybe colored screen and some other stuff. Then there are additional stuff like the cumulative instead of just the probability distribution alone. Okay? So please talk to me days before so I can prepare their minds. I'm sure they will be more than willing to help. Then this, we did something like this in the class also. Remember? A third 6 on the 5th. It means as at the 4th, you must just have a second. Hello? A third 6 on the 5th toss. It means when you toss 4 or the 4 times, you only have 2 6. So you just find the probability of having 2 6 in the 4 and probability of another 6. Does that make sense? Remember, this is one die that is tossed certain number of times. By the time you toss it 4 times, you have just 6. So there were 2 things to be multiplied. Third 6 on the 5th means you have 2 6 when you toss it 4 times, and by the time you toss it again, you have a 6. And this is probability of a 6 that is given in the question. Okay? But when you toss 4 times and you get a 2, is either you use your calculator or you can just write this. 4 combination 2, right? this raised to power 2, this raised to power 2. This probability of success, probability of failure. I hope you still remember this. Okay? Probability for binomial distribution, probability that x is equal to x is equal to n combination x. Success raised to power x. Failure raised to power n minus x. Not the other way around. I think in one paper, some people wrote n combination x, p raised to power n minus x, q raised to power x. Please. Okay, that was one an error. I'm sure it was not intentional, but you know it cost a lot. Let me see if we have that. The formula booklet also. Please always refer to this formula booklet just to be sure. We have binomial. We don't have binomial. Okay, so maybe they expect you to know. So there's no binomial apparently. Oh, yeah. But it's just the binomial distribution explanation, the mean and standard deviation, not the probability. Okay. But you can always have your binomial formula. That can help you too. Yeah? So each term, so this was the error somebody made. This n minus this, okay, is the other way around. Okay, having said that, now look at the marks allocation. Recognizing and explaining this, M1, okay, then put in this, A1, final result, also A1. Don't forget 3 significant figures, okay, 3 significant figures. Okay, the next one is regression. The following table, let L1 be the regression of x on y. I think almost everybody did this. I don't know if you did that. Did you? It's just calculator. Regression x on y. The only difference between x on y and y on x is your list L1, L2 in the calculator. You have your calculator?
Yeah, my calculator is kind of weird.
It's kind of what?
It's kind of weird.
It doesn't matter how weird it is. So where do we go? We go to exit. It's not sharp. Can you try to see what I'm doing? I want to do it for Brandy. Please zoom in into that. So we exit. Where do we find binomial? Statistics. So you find statistics. Where is it? Statistics. Then you put in this information. Can somebody give me those data? Okay, I think I can find it here. 15, 23, 25, 30, 34, 34, 40. Then you go to list 2, 20, 26, 27, 32, 35. Please check for me if I've made any mistake. Okay, once you do that, I wish this could be bold. Is it better in any way? I think the farther it is, can you help pull this out? I want to be very careful. Yes, that's this one. Does it make any difference?
It's a little.
A little? But I have to bend it, otherwise it's going to be here. Maybe we can leave it this way. Okay. Brandon, can you see the board? Okay. So, you will go to calculate. Go to calc, that is F2. Yeah, calc, that's what calculate is. We're dealing with regression, but before then, go to your set. So you have list L1. You leave that because the 2 variable we are dealing with a bivariate statistic. So we are dealing with 2 variables. So you don't have business with the first and the second. So go to the third one. So the difference between regression x on y and y on x is that for here, you change your x list to list 2. You change this to list 1. That's the difference. But if you are doing y on x simply means, okay, this one. Y on x, this one. So the equation would be y is equal to ax plus b. But here the equation is x is equal to ay plus b. That's the difference. So for y on x, you change that. So we're going to change this list of sets. How do you change the list? You click on lists. No, not this one. The third line.
Ayah. Not you yet. Not my present. List. Okay. So you come to the third one. Down. Okay. So you click on list. List number, you change it to 2. Go to the next one. List number, you change it to 1. Okay. Once you do that, execute regression of x. Then you see ax plus b. So you are going to do ax plus b now because you have changed the order of the list, not a plus bs. And once you do that, it's going to give you the values of a and b as 1.29 and -10. Okay, and that is what you have: 1.29 and -10.4. 3 significant figures. Okay, having done that, find the values of a and b. So once you do that in your calculator, you just write it down.
I wrote it out and I canceled.
Well, why did you cancel? Are you kidding me, Brandy? What is wrong with you? You just lost the point. Even if it is wrong, leave it there. Unless you have another alternative to what you have written. If you don't have an alternative, just leave it there. What's your scenario? They say 0. If you don't put anything, they say it is 0. If you put something, it's going to be 0. So why not just leave it? Like, oh, I paid for this paper, I'm going to make sure it's rubbish. Just put it, whatever you think is rubbish, put it there. You could have gotten 2 points. All right. Now, L1, L2 is a regression y on x. L1 and L2 pass through the same point. What they want you to understand is, for the line of best fit, we did line of best fit, right? For the line of best fit, we always make sure it passes through the main point. Remember that? Our line of best fit always passes. So if you have different point, the mean of x and the mean of y gives you the mean point. So you're going to make sure you draw your line such that it passes through the main point, and you make sure it balances the number of other points remaining so that it is in the middle. So whether it is y on x, or maybe you change the axis to x on y, it must pass through the main point. So basically, the only thing they are trying to test is your knowledge of this main point. If L1 and L2 pass through the same point, P, Q, then P, Q must be the main point. All you have to do is go to your table, find the mean of x, find the mean of y, and write it down. Okay? So just give some explanation. Let's look at their stuff. Recognizing both lines pass through the main point, you get M1. And calculating your P and Q as the average. So if I want to do it, Miss V, if I want to do it, P, Q must have been the main points of the data. Am I making sense? So P must be x bar, which is summation of x over n. So then you can type your calculator, put your calculator, what is summation of x? Maybe some number k divided by n, and n is equal to, I think, 7, and then you write 28 points. So you get your point. Or you can use your calculator to find the average of x and y and just put the answer. You have explained, we understand what you have done. Thank you. Now, I think the last is easy. Now you want to predict. Jennifer was absent for the first test, but scored 29 in the second test. This is just direct substitution because you have an equation already. Now, remember, this is about, the first test is x. Hello? The first test is x. The second test is y. This time around, you are predicting x from y. So you go to your first equation here. X on y. Am I making sense? Don't try to put it here. Don't try to put it on, okay, you don't even have equation for y and x anyway. But don't try to put it in that and try to make something the subject. Just go to what you have. Does that make sense? And that is what was done here. I think most people who did it, of course, find this easier. Even some people miss number B, but because they already have the equation of the first one, they were able to use it, okay? And if you notice, now the approximate value was used, right? Which is why I will recommend, this must be pizza. Can you tell them to put it on the, oh, I have to go pay. 1 minute, tell him to, if you can wait. I'm in class. So this is why we recommend don't put the last answer, so you can get a better estimate.
he's asking if he deliver it now, is that okay?
Yeah, to deliver.
可以而家送嚟 OK 啊，但係可唔可以擺喺？可你擺喺樓下。
Okay, let's continue.
未俾錢嘅。
They asked him 1 to 115, so anytime is fine.
明白。not yet paid, so you have to.
Yeah, when it comes, I will pay.
好，20分鐘到啊。
Okay,
5至7
or 1 o'clock because I don't finish my class until 1. All right, let's focus on this quickly. The displacements.
5 to 7 minutes.
That's fine. The displacement, we have to wait another 5 minutes. The displacement in centimeter of a particle from origin is given by this. Find the maximum distance. A lot of you try different approaches, very wonderful. But if you notice, you get stuck, right? And look at it, it's 3 points. They're not going to ask you to differentiate, equate, solve the complex equation, all for 3 marks. Do you understand? If this was a question and it is put for maybe 10 marks, then you can think of all those rigorous approach. Okay? Just plot the graph. Plot the graph. I like the way some of you justify that. Because of time, I use the calculator to plot the graph now. But please, if you don't know how to use calculator to plot graph, please say something. Plot the graph. Let's put it on decimals and see. Instead of t, look. Wait. Instead of t, we're going to be using x because of the decimals are. So give me the function because of time. X squared,
Plus x.
Cos x,
Plus 2x sine
plus
x.
2x sine x, like this. But from where to where?
From 0 to 5.
X is
X is larger than 0.
x is greater than 0, smaller than? Or just x greater than 0?
0 greater than X.
0 less than equal x less
Okay.
than equal to 5.
Okay, so it's like this. 0 less than equals x
Less than.
less than equals to 5. So this is what you have. So the maximum displacement from the origin, not from the origin. Find the maximum distance from point 0. Yes, that's from the origin. What is that maximum distance? This is a distance time graph. Is that? Yes, displacement time graph. So this is your time, this is your displacement. So it means you have, look at this displacement here. It's longer than this displacement here. And remember, we are not talking about direction here. We only care about the magnitude. So most of you were looking at this one. You forgot to realize of this one. And even though it is a negative, you don't have a business with negativity here. Because we are not talking about direct, we are not considering the direction. Okay? And if you click on that, you will see negative 16.5. That is why you have this. Use your graph to find the coordinate of the local minimum point. That displacement is the y value. How far is this from 0? 0 is the origin. So you are looking at the y distance. Is it this one or is it this one? There are 2 of them. Does that make sense? Within this interval, if you don't put that interval, there will be other things. Okay? So quickly, the next question is asking you, I know it's a bit technical. If care is not taken, you probably miss it. The acceleration, that's where your derivative comes in. Acceleration is the what? Talk to me. Second derivative. You see, that is 4 points. So that shows you need to do something. Okay? Find the acceleration at its first, what? Change. Find the acceleration of the particle at the instant it first changes direction. So we differentiate. Okay, find your t first, then find your second derivative and substitute. Okay? Now, how do we know where it first changes the direction? Look at this graph. Anyone?
Yeah. First time.
At the turning point. Look at it. You are moving away from maybe somebody's home, then you are coming back. So you are moving away from the origin, then you are coming back again to the origin. Then you move away from the origin, that is when y is equal to 0. It's like, oh, your distance. Your distance is, remember, y-axis is the distance. Am I making sense? Y-axis is the distance. So here, away from the distance, away from where you started from, your distance is increasing. Now your distance is reducing. Because your distance is from 0. This is your y is equal to 0. Am I making sense? So the distance now reduced to 0. Then again, you move. So it's like this is my starting point. I move away. This is my starting point. I move away, and I'm coming back again. The time is still reading, but my distance is now back to 0. Then again, I decided to change direction. So this is where I decided to change my direction, where I decided to turn back. Do you understand? So at the instant this changes, t is equal to 1.5. That can also be seen from your graph. So when you find your second derivative, you substitute that. Okay? Nice attempt, I must commend. You guys really did some nice stuff, but some people also still need a lot of things to check. Expectation. This is also another easy stuff, which I was thinking would, you know, not have problem with. Please, I need you to listen to all this because of Monday. I'll be giving you similar stuff Monday and Friday. Listen quickly, we have 3 minutes. In the city, the number of passengers, X, who ride the taxi has the following probability distribution. After the opening of a new highway that charges a toll, a taxi company introducing a charge for passengers who will use the highway. The charge is 2.5 per taxi. Remember, this is the number of passengers, right? The charge is 2.5 per taxi plus 1.2 per passenger. This is the number of passengers. It says 1.2 per passenger, so you are dealing with 1.2 times X. Per taxi, it means, so for each taxi, you have this, then for the taxi itself, you have 2.4. Somebody did 2.4x plus 1.2 mistakenly. Do you understand? So you need to read that to know. Let X represent the amount in dollars that is charged by the taxi company per ride. Per ride. How many taxis do you need in a ride? One taxi. So you don't have business multiplying this by anything. So this is what you need. So your t is simply the random variable 1.2x plus 2.4. That's what I'm trying to say. Find the expectation of t. So many ways. Somebody used long calculation, which is allowed. But if you use the property of expectation, it's just 1.2x plus 2.4 this way. And that gives you what? 1.2 expectation of x plus 2.4. So you calculate the expectation of x and substitute. Different ways people use. But then, whatever way you are using, you need to make sure your calculation is correct. If I want to do expectation of x, you know it's going to be this times this, everything added together. And then I can use for expectation of t. Okay? But what is more confusing is some of you trying to do expectation of t, look, which is expectation of 1.2x plus 22.4. I'm trying to do this calculation in a complex way. So somebody did 1.2 times x, which is 1, plus 2.4, then everything times 0.6, then plus the next one. Why do you want to go through this stress? The more numbers you have, the more complex. How do you even want to trace your error? Okay? Do simplify, simplicity. But of course, it's more simplified work. And variance, we have something for variance, isn't it? Can you tell this guy I'm coming down in 2 minutes? For variance of t, which is the variance of 1.2x plus 2.4, okay, it's going to be what? A squared, right? Hello? Times variance of x. Okay? And then you can substitute. Oh, we have variance of x already. So variance of x is given. So we just substitute what? 0.8419. Then whatever